And today we have Dr. Elizabeth Sudduth, who is the professor of biology and environmental studies at Georgia Gwinnett College in Atlanta, Georgia. She's a former FPC member. She did her master's at NC State and a doctorate at Duke. And while she was at Duke is when I met her as a member of the Crossroads Young Adult Group. And then she was responsible for bringing George and Johanna to the choir and FPC. So we have a lot of things to be thankful to her about. And so without further ado, we bring you Elizabeth Sudduth.
It's great to be back at First Pres. I miss y'all. So we're going to start by looking at this little stream right here. So this is Cemetery Branch in Raleigh. It is in the Oakwood neighborhood, and as the name suggests, it drains Oakwood Cemetery. And looking at it, you can see some of the things that make an urban stream, some of the things that happen to a stream when we build a city all around it. You can see that the banks are very steep. You can see there's no vegetation right next to it particularly, which there usually is. You can see that the bottom is very sandy. You can see that over here there's a sewer line, and it's very common as we build our cities that we put sewer lines right next to our streams so that gravity can transport sewage. You can see it goes through a culvert here under a road. And so this is sort of a symbol, a good representation of all the things that happen to our freshwater resources as we build our cities. And my title, We All Live Downstream, it sort of has several different meanings. We all live downstream is a common phrase used by people who study freshwater resources. And one meaning is sort of a very Christian sort of meaning, that we all live downstream of our neighbors and are affected by what our neighbors do to the stream. And in turn, we're all the upstream neighbors of somebody else who lives downstream from us. And so first, let's just think about that version of we all live downstream and of caring for creation is, oh, we have a responsibility here if we care for our neighbors to care for our freshwaters. Another way to think about we all live downstream is to think about the fact that how water moves, water runs downhill. So we all live in a place, literally where our home is, that then water runs off of and runs down into somebody's stream. And what that looks like and how that changes really depends on what the place you live in looks like. So in a forest, when the water hits the ground, most of it goes into the soil. Some of it goes into the shallow soil and is used by the trees. Some of it goes into the deeper soil and ultimately ends up in the groundwater. A good bit of it will evaporate, and only a small amount will run off the surface of the ground and end up somewhere else in the stream. As we move into a rural area where people actually live, we start putting in roads, and we start changing those numbers a little bit. With just a few roads and a few houses and driveways, less water is going into the ground and more water is running off the surface. As we move into a city, into a developed suburb or a semi-urban area, we get now a lot of roads, a lot of houses, a lot of driveways. Much less water can get through all that pavement. And so more of it ends up hitting something hard, what we call an impervious surface, and running off to a stream. And of course, when we get to downtown Durham, there's hardly anything green anymore, right? That's just sort of a consequence of a city. And so much less, there's just less land where the water can go down into the soil. And most of the water that hits the ground ends up running off straight into a stream. We all live downstream of that. And so when we think about what happens to our urban streams, that first picture, how did we get there? So we changed the hydrology. And now most of the water flows over the land. It goes into a storm sewer probably. And then that pipe delivers that water straight to the stream. So we changed how the water gets to the stream, and especially how quickly and how much water gets to the stream. Changing that changes geomorphology. So geomorphology is the shape of the land. So if we have, now we're putting more water into the stream and faster, we're stimulating erosion. And so we're taking the stream channel that used to be shaped like this, and we're making it shaped more like that, like what you saw in that first picture. We call that incision. It's just a deep, narrow channel. And that change happened because all that water got to the channel very fast. There's a lot of it, and it just washed the channel away. We're also changing the quality of the water that gets to the stream. Water that moves, as you can see in this picture, through the ground. By the time it gets to the stream, the soil has done a lot of cleaning of that water. When that water moves over a street, into a pipe, into the stream, whatever was on that street ends up in the stream. And so our water quality gets worse. It could be straight from the street, oil and gas and bits of our tires and things like that. It could be from your yard, the fertilizer and pesticides that are used in your yard. All of that is going to enter that stormwater pipe and get sent straight to our urban stream. And then, of course, all of that affects the things that live in the stream. And so we took this forested stream with this nice shallow rocky channel, and we took away the forest and we made the channel a lot deeper. We changed the habitat for the things that live there. And that's, on the one hand, well, that might not affect me, but on the other hand, in terms of care for creation, we have hurt the creation if we destroy the habitat for the things that live there. And ultimately that affects biodiversity. Fewer things are even going to be able to live in that place. And I should say, please stop me, ask questions. I teach undergrads, 12 hours a week, and some of them are really good about interrupting and asking questions, and some aren't. Feel free to ask questions at any moment, or tell me a cool story or anything.
Folks can also put things in the chat, and
oh yeah,
Johanna will read them. I'm just saying that out loud.
Okay. Thank you. By all means, use the chat. Many of my students have not turned on their microphone all semester, but they will chat. So by all means, chat. And so in many places, this is what we're left with. This is actually a sign from here in Atlanta. This is a stream that I work in, and it's a lovely park. It's on the Beltline, which if you know anything about Atlanta, you may have heard of the Beltline. It's this big trail that will ultimately go all the way around the downtown Midtown area. And right next to this huge trail we're very proud of is this sign. Many of our streams are not safe, not just for the things that live there, but they're not safe for our kids to play in. They're not safe for dogs to drink from. And in this case, it's primarily due to leaking sewage, which is another issue, because remember in that first picture, that sewer line was right next to the stream. Sometimes those sewer lines leak, and sometimes we fix those, and sometimes we just put up signs saying, don't touch the water.
Oh.
Another thing you see in Atlanta, and this is from the Chattahoochee, people fish in the Chattahoochee. And this, I think this picture is under 285, our perimeter road that goes around the city. Yeah, people fish in waters that have signs like this. And so it becomes a public health issue. And some of those people are fishing to get enough food to eat, especially among our Vietnamese and Hispanic immigrant communities. Fishing is part of their diet. And so then that becomes dangerous in other ways, because we're directly affecting people's health. And of course, in this park next to the sign, there's this playground, and kids can't read the sign. And so there's a whole world of what we'd call environmental justice. Are we doing a good job of caring for all of our neighbors in the process of how we care for our fresh waters? So first of all, a lot of us would really like to know, well, what can I do? And there are some things that you can do. Going back to this ideal of we all live downstream, how can I protect my downstream neighbors? You can change how you manage your yard. This is an idealized version of what we call low impact development, targeted at reducing the amount of water that ever leaves your yard in the first place, reducing your contribution to those changes. And so you've probably heard of some of these things before. They've got rain gardens, which are depressions filled with rocks and sand, and then plants on top. And so the water from your yard would go in there and soak into the ground instead of going into the street and ending up in the stormwater system. They've got a permeable pavement driveway. These are very trendy. Unfortunately, in red clay, permeable pavement ends up not working great. Usually the little holes that are supposed to let the water go through your driveway end up clogged with red clay pretty fast. But in Durham, you certainly see people who just have the two little strips of pavement for their tires and they've planted grass in between. Things like that, you're reducing the amount of pavement. That can certainly help. You can see here, instead of a storm sewer, they have an open grassy ditch. Well, some of that water is gonna soak into the ground instead of just being into a pipe. A lot of folks have the rain barrels that capture the water as it comes off your roof, and then you can use that to water in your yard. And then of course, in this yard, they've also got some efforts at conservation. Maybe we don't need a green lawn with fertilizer and pesticides. Maybe we can just have some native vegetation as most of our yard. And that will, again, provide places for the water to soak in and also reduce the amount of that stuff that ends up washed into the streams. So there are things you can do. They create a hydrologically functional lot. There are things you can do. However, if you do this, but none of your neighbors do this, then obviously the impact is very small. It's hard for any one of us to solve these kinds of problems. So I have a question?
Yeah.
Okay, I'm sorry. I thought I heard somebody say something. And so ultimately, just like maybe some other problems y'all have talked about, like climate change, we probably can't individually fix this. It probably is going to require larger solutions. So if you live in the Triangle and have ever gone for a walk, you probably are aware of the idea of stream restoration. There are a lot of stream restoration projects in North Carolina, especially in Raleigh and Durham. And so this is an example of a pretty famous one. This one is on the NC State campus. When I attended NC State in 2000, Rocky Branch looked like this. Again, a very classic bad urban stream, really steep banks, really sandy bottom, no plants growing next to it. And so they came in and did a stream restoration. They changed the shape of the banks, they changed the shape of the channel, they added a bunch of plantings, and they got it to look like that. And this is what it looks like when it floods. And so instead of the water continuing to erode this channel away in every storm, they now have a channel that can handle the big stormwater floods. Hey, that's really cool. That seems like, well, maybe we can solve some of these problems. And so when I started grad school, I was really passionate about this idea of trying to fix what we did to the stream. The bad news is, if it's going to look like this, if it goes from this to this, it has to look like that along the way. And from the beginning, when we first started doing these stream restorations, a lot of folks had questions about doing this. Does it make sense to bring in this heavy equipment to do all this? So while I was at Duke, one of the projects I worked on was trying to understand the effects of these urban stream restoration projects in the Triangle. So this is an example of how our study worked. We had forested streams, and this is Stony Branch in Duke Forest, close to Hillsborough. We had urban degraded streams that we had not tried to fix. So this is Ellerby Creek in Northgate Park. And then we had urban restored streams. So this is Third Forks in Forest Hills Park. And so our goal was to see, has that changed a stream that used to look like this into something more like this? And so I put the restored stream in between, because the question is, does it still look like that, or does it actually now work more like that? So this was a large team effort, and this was one of the things that Johanna worked with us on, collecting data at the 12 sites for this study. We collected a bunch of different kinds of data, looking at hydrology, at the shape of the channel, at the water quality, at the macroinvertebrates, which are the insects and worms and clams and snails and things that live in the stream. Just because, as you can imagine, the things that live there tell us a lot about how the stream is doing. And our hope, of course, was to see that this lovely, interesting thing in Forest Hills was more like this than like that. So here is what we found. The habitat in the restored streams was not that different from the habitat in the degraded streams. As you can see, just looking at these pictures, bringing in all those bulldozers meant that we had lost the canopy cover. You can see this stream is much sunnier even than Ellerby Creek is, that they took out the trees right next to the stream in the process of working on the channel. And so losing that canopy cover means it's sunny and warm, and things have changed in there. We didn't find any change in water quality. The urban streams had poor water quality before and after restoration, and that was reflected in the macroinvertebrates and the things that lived there. We did see some evidence that the urban stream might be taking up nitrate, which is a form of nitrogen, better than regular degraded urban streams do. But we think that was part of the loss of canopy cover meant in summer, this stream was just full of all kinds of algae and microbes. And we think they were eating up that nitrogen. So yeah, that's good. That's an improvement, but it might be an improvement for the wrong reason. So that's pretty discouraging, especially when I tell you that these things cost millions of dollars. And so spending millions of dollars to take out the trees and change the channel shape to not necessarily get many benefits is kind of disappointing. They usually happen at pretty small scales. They're really expensive. So you're not going to fix a whole stream. You're going to fix the reach through the park that everybody sees. And lots of small scale projects are kind of uncoordinated. People aren't kind of thinking, well, how could we do this to fix the whole watershed and fix what's the worst? They're just kind of doing it where it's convenient, which, like I said, is often in parks. And we're just not seeing evidence that this helps. So what can we do? This is really frustrating. So this is moving us into now from the early 2000s to the 2010s and 2020s, thinking about finding ways to better help creation care for itself. Instead of us thinking, I know how to fix this, trying to help the natural processes fix things. And we have enough time. I'm going to play you this video to give you an idea of what I mean. You may have seen this before. It went around on social media a few years ago. And it's not urban, but it's a nice idea about how we could return to natural processes rather than trying to do things ourselves. And I hope the video follows.
One of the most exciting scientific findings of the past half century has been the discovery of widespread trophic cascades. A trophic cascade is an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom. And the classic wolves were reintroduced in 1995. Now, we all know that wolves kill various species of animals, but perhaps we're slightly less aware that they give life to many others. Before the wolves turned up, they'd been absent for 70 years. That the numbers of deer, because there was nothing to hunt them, had built up and built up in the Yellowstone Park, and despite efforts by humans to control them, they'd managed to reduce much of the vegetation there to almost nothing. They'd just grazed it away. But as soon as the wolves arrived, even though they were few in number, they started to have the most remarkable effects. First, of course, they killed some of the deer, but that wasn't the major thing. Much more significantly, they radically changed the behavior of the deer. The deer started avoiding certain parts of the park, the places where they could be trapped most easily, particularly the valleys and the gorges. And immediately those places started to regenerate. In some areas, the height of the trees quintupled in just 6 years. Bare valley sides quickly became forests of aspen and willow and cottonwood. And as soon as that happened, the birds started moving in. The number of songbirds and migratory birds started to increase greatly. The number of beavers started to increase because beavers like to eat the trees. And beavers, like wolves, are ecosystem engineers. They create niches for other species. And the dams they built in the rivers provided habitats for otters and muskrats and ducks and fish and reptiles and amphibians. The wolves killed coyotes, and as a result of that, the number of rabbits and mice began to rise, which meant more hawks, more weasels, more foxes, more badgers. Ravens and bald eagles came down to feed on the carrion that the wolves had left. Bears fed on it too, and their population began to rise as well, partly also because there were more berries growing on the regenerating shrubs. And the bears reinforced the impact of the wolves by killing some of the calves of the deer. But here's where it gets really interesting. The wolves changed the behavior of the rivers. They began to meander less. There was less erosion, the channels narrowed, more pools formed, more riffle sections, all of which were great for wildlife habitats. The rivers changed in response to the wolves. And the reason was that the regenerating forests stabilized the banks so that they collapsed less often, so that the rivers became more fixed in their course. Similarly, by driving the deer out of some places and the vegetation recovering on the valley sides, there was less soil erosion because the vegetation stabilized that as well. So the wolves, small in number, transformed not just the ecosystem of the Yellowstone National Park, this huge area of land, but also its physical geography.
So I hope you found that entertaining. I think it's an amazing story. And now let me tell you how it's relevant to what we're talking about. Obviously, we're not going to reintroduce wolves to Durham. And it's not clear that reintroducing wolves would solve our problem. But there are other natural processes out there that we have not fully embraced. And one of those is beavers. You saw beavers in the video, but beavers are in Durham. They're in our urban streams, and they can help guide the natural processes that can make our streams work better and make our streams work more like they did before European colonization and before we hunted all the beaver. So sorry, go ahead. Before colonization, beavers inhabited basically all of what's now the US and Canada down into Mexico, with the exception of parts of the desert of the West and parts of Florida. And then we hunted them nearly to extinction to mostly send furs back to Europe to make hats and coats. They were incredibly popular for that in the 1800s into the 1900s even. And it was only as that went out of fashion basically in the 20th century that beavers started recovering. There were still beavers present throughout much of the country, and they began to recolonize everything. But for many of us who grew up in the 20th century, we aren't used to beavers. They weren't really a thing for most of our lives. And now they're kind of everywhere again as they've reestablished to their old range. And so in Durham, in Raleigh, in Atlanta, we see this all the time in our urban streams. The beavers are just there doing the best they can to build dams in these not very hospitable locations. And you can see this dam has a hole in it. A big storm came up from all that impervious surface cover and washed the dam away. And that happens to them a lot. But sometimes they get a dam in just the right location. And I think you can kind of see in this picture just how much this dam has flooded back behind it. And in this case, off to the left, there's a wetland. And this dam reconnected this stream to the wetland that hadn't been connected to it in years. And so sometimes our urban beavers working all by themselves are doing a pretty good job of restoring some of those natural processes. And so when you have a dam like this, well, we're slowing the water down. Those big storm flows are going to be slower now. We're capturing the sediment moving through that eroded upstream. So we're stopping that erosion and that channel deepening. And we're providing a wetland that can improve water quality as the things living in the wetland take up that nitrogen and phosphorus and process those pesticides and oil. The water that comes out of these beaver dams is cleaner than the water that went in. And so these natural processes are already happening. And now the question is, can they do it? If we get out of their way, can the beavers fix what we have messed up? So the idea of how this could work has been proposed mostly by Western scientists. Beavers recovered more quickly in the West than in the East because, hey, there's a lot more natural stuff in the West where the beavers can come from. Yeah, so the Sandy Creek Restoration Site was one of the sites we studied, and the beavers were not there when that project was installed, and they weren't there in the time I was working on it. So that's really cool that they've moved in there now. That project was no more successful than any of our other studied projects in terms of improving the metrics we were looking at, but I'm really hopeful that the beavers could help fix it, because one of the problems there was they really wanted the area around it to flood in storms, and it wasn't flooding. And so the beavers can help with that, just like you saw in that previous picture. Oh, so this is a diagram from a Western stream where they don't have quite the same problems we have, but it's similar. So imagine, like I showed you those pictures where our incised urban stream, the beavers come in and build their dams on Sandy Creek. Well, the first thing that's probably going to happen is sooner or later, those dams are going to erode. The dam's going to get blown out in the process. Some of that deep channel is going to have some more erosion, and things are going to kind of look worse. That deep, narrow channel is going to get wider, and some of those trees are going to fall in. Well, that doesn't look so good, but the beavers will come back and do it again. And now they've got their dams across that whole big wide channel. They're going to handle the storm flows better. It's going to take longer before the storm flow blows out their dam. And the time being, that gives a time for the vegetation to start establishing in that channel. So when those dams blow out, we're left now with the channel's not as deep. It's got more vegetation. It's starting to maybe have some little side channels to it. And then the beavers come back and do it again. And now they've finally gotten up to where the water level in their channel is now matching the surface around what used to be that deep channel. And eventually we could end up with a system like this, just their stream reaches flowing in kind of all directions. There's trees everywhere. There's beaver dams everywhere. And this is what our streams looked like before European colonization. It really hurts our heads because we think of streams as those nice, meandering single channels, but this is really what our streams used to look like. And so if we get out of the way and let the beavers do their jobs, they could bring those streams back to this. And now those streams could even handle those storm flows. They can clean up that poor water quality. They can provide good habitat. And so this is where we're hoping integration is going, is if we encourage and support natural processes instead of trying to bring in a bulldozer and fix it. So this is a project I'm working on in Atlanta right now. This site used to have beavers, but the beavers left, but we still wanted to see can beavers help improve this site. So we put in what are called beaver dam analogs, which are fake beaver dams built by people. So the city of Atlanta got a grant to do this, and they put in 12 of these along the stream. And now it's just a game of us playing beavers, trying to figure out how can we maintain these and encourage those natural processes to happen. in the face of storms and erosion and all those other things. So that is a possible promise for how we can better care for creation in the future, is by letting creation do its natural things. So I will stop there and chat with you. Ask me questions, anything you want to talk about.
What stream is that you're putting the fake beaver dams?
It's called Mill Creek. It's in Blue Heron Nature Preserve in Buckhead. It's right off Roswell Road.
Yeah. Okay. Elizabeth.
Yeah.
I know that Durham has regulations about how much impermeable surface you can put on property that you're developing. I wonder if many cities are doing that, and if that at least is some help.
That's absolutely some help. So that, yeah, that's becoming increasingly common. Another thing that they do is just charge you higher tax based on how much stormwater would come off of your property. And so then that raises money to manage things downstream. In the West, like in Tucson, any stormwater that comes off of your property, you're responsible for it. You have to manage it. You're not allowed to have any runoff leave your yard. So there are different approaches, but yeah, just having a rule that says, well, your lot can't have more than this. You figure out how to stay under that limit is a great way to try to do it.
Yeah.
I have a question. We live in a planned community in Durham, and a decade or so ago, I was president of the Homeowners Association when the city got the idea that we should have stormwater retention ponds. And we were required at the cost of many thousands of dollars to put in these depressions in the ground and plant grass in them and maintain them, which were in some way supposed to control stormwater runoff. Do you know whether those ponds have turned out to be effective when they've been applied in urban settings?
So they can be. So that's very similar to what I showed you with the low impact development in your yard. It's just sort of managing the stormwater for a neighborhood instead of for a yard. And they can be. Sometimes they have different designs, and some designs are just built to slow the water down, which slowing the water down is good. Some are built to retain the water and encourage it to soak into the ground, which can help improve water quality. But yeah, they can definitely be effective. Of course, it's much more common for newer developments to have them versus, old areas like downtown. There's not even a place to put one, so it's not, it can't be the only solution, because there are places where it wouldn't work because you don't have any land to put one. But in a place you have the land, yeah, they can help.
Thank you.
Yeah.
Let's see. So Elizabeth, this is Chris. So I was thinking, we have a place up in the mountains where there's a constant struggle with folks that this is not an urban question so much as there's a stream that goes through, and people don't like the beavers like eating their trees and creating their own habitat. So they've been like trying to kill the beavers. And so there's this constant battle about letting them do what they want to do, because there's the idea of property, and this is our land, and I can do whatever I want to do with my trees. And this is not so much as a question, but I just know that there's, just wondering about what, just if there are people, and I'm just thinking in an urban situation where, there are people living close to these banks that might not want their banks eroded because, even though it'll help stream quality, their trees would go away. I don't know if there's if you've had any pushback in these urban areas with people not wanting these things flooding.
Oh yeah, there are people who hate beavers. The TV show Duck Dynasty, I guess that guy really doesn't like beavers, and so a lot of people who watched that show got the idea beavers are just bad. In terms of human beaver conflict, there are lots of different ways to manage it. Sometimes people just don't want, I planted those trees. I don't want the beavers to eat those particular trees. And that can be fixed as simply as wrapping chicken wire around the trees so that the beavers don't eat them. If it's a problem with flooding, sometimes there are devices you can use. They call them beaver deceivers. So beavers, they sort of have a compulsion when they hear flowing water, they want to make that sound stop. And so you need to trick the beavers into not continuing to make their dam higher by making sure they can't hear the water flow. And so a beaver deceiver basically, I don't know if you can see my pointer, you put a pipe farther upstream of the dam and then have it go underwater and through the dam to let water out far away from the dam so that the beavers can't figure out where the water is going. They don't hear the sound, so they don't work on the dam. And those help in places like, okay, in our park, we're fine with the beavers here, but we need to not flood the parking lot. So the water can't get deeper than this or it starts flooding the parking lot. And so in those cases where it's not that we don't want the beavers here, we just need to control how much they flood. There are devices like that.
That's cool.
Our main focus is trying to find places like this nature preserve in the middle of the city where it's fine for the beavers to be, knowing that there will always be places that it's probably not a good idea for beavers to be.
Thank you.
Yeah.
And I know that we had wanted, I don't know if you are, since you've been in Atlanta for a little bit now, if you, we were going to have next week have Ricky from Ellerby Creek, but he's going to come a little bit later into one of our meetings later. But I don't know if you know much about what they've been doing, or if they've been doing anything like this.
I know a little bit. Just completely coincidentally, we're collaborating with a professor at UNC who happens to have Critty Whitmore as one of his grad students, and so I know because she's told us some about what's happening in Ellerby Creek. I know that they are encouraging the beavers in that wetland that I guess is behind the old Kmart.
Very cool. Yeah. All right. Does anyone have any other questions or comments?
Well, I have a comment. It's Marcia. So, we lived in Forest Hills for a good number of years and lived very close to the stream, which was diverted. And I would say that people working on these projects need to have good communication with the citizens around, because there was a lot of misunderstandings and even though the board of the Homeowners Association, which is not really a homeowners, it's just a group of people, even though they interacted continually because it was run by the government, at least that's what we were told, we didn't know what was going on half the time. And some of the citizens were pretty upset, including Judge Carr, who I remember wrote a scathing letter to the editor of the newspaper. And he said, this is an urban park. We should let it be an urban park and we should not try to change it. And the other issue that we had was we couldn't control the garbage that was coming downstream. And then we couldn't even get close to the stream to clean the stream once it started getting rehabilitated. So it seemed to us that there was more garbage. I think there needs to be a communication plan and plans for citizens to be part of the rehab.
I completely agree. I think that has been a weakness of the North Carolina program, is there's so much money to go in and fix streams that they probably don't, because they have permission to do it, they don't work as hard as they could in communicating with their neighbors. And it can be hard. There are always people who may just miss the communication they're trying to do. The trash issue is funny because, of course, beaver dams are great at catching trash, as you can imagine. And so people tend to blame the beavers for the trash that they see, when, of course, it's the people upstream who put the trash in. There's a whole thing now in Atlanta. I haven't seen pictures of them in Durham. I don't know if they're doing them, where they're putting in these trash collectors that are, they're like wire baskets that float on the surface and catch trash.
Wow.
they've been wildly successful. Of course, you have to have people who go in after every storm and pull out the trash, but it's really a pretty cool thing. And they put in one just upstream of one of our beaver dams. And it's been so nice because now our beavers aren't getting blamed as much because all the Chick-fil-A cups are being caught just upstream of the beaver dam instead of in the beaver dam. But then, of course, like I said, so you have to pay for the collector, and then you have to have volunteers or somebody who's able to go out and take the trash out all the time. And that's a commitment.
Yeah.
Thank you for that, Marshall. If there aren't any other questions, I think we can see. Let's can you unshare?
Oh yeah, I'm sorry. Absolutely. I had forgotten I was still sharing.
You can see the people. Well, thank you so much, Elizabeth. This is really, thank you for taking the time to prepare this. This has been a treat to see you, and we miss you and hope that you can come back to Durham one day to teach and to be with us at First Pres. Johanna, is there anything else?
We're just so glad Elizabeth could come and share what she's doing through the years. Yeah.
Amen.
It was so good to see y'all. Thank you so much for having me.
Yeah.
Thank you. Thank you, folks, and you have a really good Earth Week. So I'll make it quick. Just by saying that there's a weekend reminder that has a whole bunch of lists of things from the Creation Care Committee that you can do. It has some links to our upcoming, the first issue of our newsletter when it comes out, plus some other activities that's in the weekend reminder and will be in the newsletter coming up.